Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at a Doppler effect type of question. Okay, yes. So now it says now a police van with its siren on travels at a constant speed between two observers, A and B. Okay. Observer A detects sound with frequency 545 Hz from the siren, while observer B detects a frequency of 615 Hz. So can we see this one detects a higher frequency, then this one detects a lower frequency. So my assumption is that uh, if here is a police van like that, a policeman. With a siren there. Okay, I know the siren it is inside, but I want you to see it like this. Oh, okay. The one that detects a higher frequency, means it is approaching. Okay, let's say it is moving in that direction. Okay, with a speed of whatever that speed is, then it is approaching. Which one has a higher frequency? Approaching B. Approaching B. Then it is moving away from A. Okay, this is my assumptions. Why? Because now B detects a higher frequency compared to A. So I want to believe this one it is moving away from it. Okay. Mm. State Doppler effect in words. The definition that you should be in a position of knowing. It is long, but you should know it. It says now the apparent change in frequency of the sound because the sound source or detected, okay, let me repeat that. The apparent change in frequency of the sound detected by the listener because the listener and the sound source have different velocities relative to the medium of sound propagation. Okay, yes. There's the other definition that says the change in frequency of the sound relative. Yeah, I can't remember it. I used to know it, but I was told that we should be in a position of knowing this definition that talks about relative motion between the two. Okay, yes, but you can know whichever definition you know. They're asking in which direction is the police van moving? Okay, choose from towards observer A or towards observer B. Now we are saying it is going to be towards observer B. Okay, why? Because the detected frequency is high. Okay, we do not know the frequency that this one emits, but now frequency B, I'm going to answer it here. I'm going to say, wait, B detects a higher frequency than A. Do not say frequency of the listener is greater than frequency of the sound source. Why is this wrong? This is wrong because you do not know the frequency of the sound, so you cannot compare. So you can compare between B and A. So B detects a higher frequency than A. The speed of sound in air is 343 meters per second. Calculate the frequency of siren. Now here we want to calculate the frequency of the source. So what will we do? We'll say 6.3. We'll need to use simultaneous. Why? Because 7 marks. Yeah. First thing first, I'm gonna say, let me calculate for 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 object A. Object A. So it's gonna be frequency of the listener is equal to V plus or minus VL divided by V plus or minus VS, frequency of the sound. Okay. Now, object A, they are moving away from object A, so it means the top will be negative, the bottom will be positive. So frequency of the listener by A, it is how much? 545. 545 hertz, it is equal to V. Okay, V it is constant 343, or wait, it is 343 minus, because it is moving away from it again. Velocity of the listener, it is at stationary. Okay, what is moving is the siren. Therefore, 343 plus Vs. We also don't know the speed of the of the what? Of the a van, or the what? Not the van. Yes, the van, the police van. Okay. Multiply by frequency of that one. Okay. So what I can do, I can say, how can I do my mathematics here? I can do my mathematics by saying now frequency here. I want this frequency of the sound. I'm gonna say, okay, let me do that. Or no man. Ish. Okay, let me just multiply this to the other side, okay? Let's just say it's gonna be this one to the other side. It's gonna be 545 multiplied by 343 plus VS. I try by all means to run away from calculate. Then when I multiply that to the other side, then I divide by 343. Oh, all right, it's fine. Let me say it is what? 343 FS, like that. Okay, 343 FS, like that. Then this is equation 1. Then for object B, they are moving towards object B. So it's going to be frequency of the listener. Okay. Then it's going to be V plus or minus. It's fine. We'll repeat the formula. V plus or minus Vs, frequency of the sound. VL detects how much object B it is moving towards. Okay. Towards it is 615. 615. It is equal to 343 plus, again, if this is moving towards, okay, towards, then that is away. That is away. Away signs, it is negative divided by positive. Okay. Towards signs, it is what? Positive divided by negative. Like that. So it's going to be positive plus 0. Velocity of the listener, it is 0 divided by how much? 343 minus Vs. Fs. So it's going to be what? 615 multiplied by 343 minus Vs, it is equal to 343 Fs. So this is equation 2. Can you agree with me that they are both equal to what? They are both equal to 343 Fs, 343 Fs. So I can say, therefore, it means now this part. Amen. It means now, let me copy that. Let me copy that and paste it here. Paste. Right. Then copy this one. Copy and paste. Okay. So we said this is equation 1. This is equation 2. Therefore, they are all equal again. They are both equal to this one again, 343 Fs. So we're going to say equation 1, it is equal to equation 2. Then I'm going to say this is 543. So 545, 343 plus Vs. It is equal to 615, 343 minus Vs. Let me do my mathematics here. I don't like doing mathematics here. But it's fine. Let's just simplify the mathematics. 541, 545 multiply by 343. I have 18, 6, 9, 3, 5 plus 545 PS. It is equal to minus 615 VS. Then here I have 615 multiply by 343. 210, 945, like that. Then I take VS to the other side, it's going to be 545 VS plus 615 VS is equal to 210, 945 minus 186, 935. Then here I get VS. I will do your mathematics. I'm tired. Answer minus 186, 935. Okay. Then you divide by 545. Actually, let's do it together because people will be lost. Let's do it together. This here I get 24, 0, 10. On this side, I get 10, 1060. Yes. 24, 0, 10. Let me quickly do that. 5, 4, 5 plus 6, 15. Yeah, I'm lying. Ah, oh yeah, 11. 11. Eh? Yeah, 0 carry that. 1 plus this 6, then 6 plus 5. Oh, yes. Then now VS is going to be equal to how much? 24, 0, 10 divided by answer. You get something like VS it is equal to 20.698. Okay? Why? This is not the final answer. Therefore, you need to come back to any of these formulas and substitute for for FS. Okay? So if I take any of these, I can substitute in this one and say, okay, let me substitute on this one and say it is 615, 343 minus 20.698, 3.3 Fs. So divide by 3.3 Fs again. Frequency of the sound, not Fs like this free state, no. Fs. Therefore, I get something like 615, 343 minus, I'll just say minus answer from my calculator. Then everything divide by 343. I get something like 577.89 hertz. Okay, I get something like that. Or if I use the value thereof, I get something like 20.6 and 8. Yeah, so 577.89 hertz. So that's all for that one. 6.4 says spectral lines of certain gas observed from distant stars appear to be redshifted. Okay, explain the observation by referring to the motion of the star and frequency of the frequency of the spectral lines. We know that motion of the star, the stars are moving. Stars are moving away from the earth, away from the earth. Okay, from the earth we have talked about the motion, okay, and the frequency towards lower frequency. Remember, when you are redshifted, you are moving away from the star. Okay, sorry. If you are redshifted, you are moving away. Okay, but in this case, we are talking about the stars. So the stars are moving away from the Earth and now towards the what? The lower frequency. Remember, redshift, you are moving towards the lower frequency, but what? Higher wavelength or longer wavelength. So that's all. For 2 marks, it is moving away from Earth towards the lower frequency like that. Okay. Then here 7 marks formula substitution. Substitution. Okay. Doing your mathematics here, equating the two. Then this one, I think this is 2, 4. I just gave it 5 for now. 1, 2, 3, 4, 5. Then I think, I don't know, 7 marks. Maybe for seeing this one, it is moving away and that one, whatever the mathematics there. So yeah, that's all for this one. Let's meet on the next one again, where we discuss also the very same topic questions. Okay, thank you very much. I hope you enjoyed.